Hello, this is Team 4, including me, Wilbur Alderjust, and also Naira Foster and Brian McLean. And our project that we're going to be proposing is the bicycle rental system. So, so time is a precious commodity, especially for college students. When dealing with work, school, social, and other aspects of life, any way of saving time would be welcomed. The problem of walking across campus is one which is encountered by many students. During the hot summers, one can quickly succumb to intense heat rays that they would be exposed to while walking from one end of the campus to the other. During cold winter days, one can quickly become uncomfortable with the frigid temperatures. South Florida is notorious for stormy seasons, where students have been exposed to torrential downpours while walking across campus. There are also reports of bike thefts throughout the campus, when in reality, bike thefts are of a rare instance. And the main reason for the reports of bike thefts involves students wanting to find a convenient method of getting around campus and resorting to the use to using bikes left unlocked as a way to get around. So to solve the problem of having to navigate great distances across campus, a bike rental system is being proposed as a resolution. To properly implement the system, a set of goals and objectives must be met. A bicycle which is all encompassing must be used. In other words, all the components used to operate the system must be located on the bike itself. The bike must have a means of tracking itself automatically as to know where to retrieve the bike when it has either been left in an area where other students are less likely to reuse the bike, or when the bike has been taken out of the predetermined perimeter of operation. The bike must have the capability to withstand various weather conditions. The bike must be able to communicate with a phone application via wireless connection. A phone application must exist to allow the user to sign up for service and use the application's interface to locate an available bike for use. A design must be incorporated to include a locking mechanism which will secure the bike and does not allow the bike to be operated when it has not been rented. The design will also incorporate a security feature which will automatically detect when the bike has been taken out of the perimeter and sound an alarm. So basically, the bike rental system will include a bicycle, a tracking system, a smartphone application, which will allow the user to sign up for service and use the application's interface to locate an available bike, a locking mechanism, and a security feature that will um, detect when the bike has been taken out of the perimeter. So the bike rental system will be a system that will incorporate all of the subsystems directly on the bike itself. The main module, along with the GPS, will be located on the bike. The portion of the bike frame, which is called the top tube section of the bike, will be used as the attachment for the module. The module shall be in a compact enough form as to not interfere with the usability of the bike and allow the user full range of pedaling motion while the bike is in operation. All of the components involved with the module shall be enclosed in a waterproof box. This weatherproof box will incorporate enough ventilation to allow the module enough airflow to control its temperature. The module will also be battery operated. A bike mechanism attached to will be attached to the front fork of the bike, and this mechanism will allow the bike to be locked. A wire will run through the hollow section of the bike frame and to the box that will house the module. Pictured on the screen is a depiction of the block diagram, which consists of three major systems. Um, it includes the main module, the GPS module, and the phone application system. For the GPS module, the processing unit is in a low power state until the vibration sensor senses a vibration for a certain period of time. At that point, it will tell the central processing or the GSM module to come out of a low power state and send periodic signals to the phone application at specific intervals.
Hello class, this is Brian McLean and I'll be going over some of the sensors and the modules and the microcontrollers we'll be using in the system. The first one is a microcontroller Arduino Uno. This microcontroller uses the ATmega 328 chip. It has 14 digital inputs, input-output pins. You can switch it using the code, internal code. 6 analog inputs and a 16 megahertz ceramic resonator, a USB connection, a power jack, an ICSP header, a reset button, and it's made by a variety of different companies. It can have a 5-volt input. The max current for the digital pins is 40 milliamps, and for the analogs it's 50 milliamps. And it has a clock speed of 16 megahertz. The next module that we'll be using in our system will be a GPS and GSM module that can be used with the Arduino. So this module has a GPS module and a GSM module built onto the same board. It can give the tracking position with using the navigation, and it can also send GSM messages over 2G, 3G, or 4G network. The power supply can range between 5 to 12 volts, and it needs at minimum 3 volts to actually operate. Any lower than that, and you get an error in the code. It has a low power consumption mode. It will draw about 1 milliamp in sleep mode, and it uses a standard micro SIM card. The next module is going to be the Bluetooth module. Some of the software features is it has a default baud rate of 38,400, has data bits of 8, stop bit of 1, And given a rise pulse in PIO0, device will be disconnected. And status instruction port PIO1, that gives low disconnected, high connected, and so it can easily be the device can easily be turned off and on given a high or low to that port. It also has other features like it auto connects to the last device on power as a default. Um, it permits the pairing device to connect as default, and auto pairing the pin code is 000 as a default, and it also auto reconnects in 30 minutes when disconnected when it's out of range. The Bluetooth module has an operating voltage between 4 and 5 volts, an operating current of 30 milliamps. Its range is a little under 100 meters. It has about a negative 80 dBm sensitivity, up to a 4 dBm RF transmit power, has a low power 1.8 operation, and PIO control, and it has a UART interface with programmable baud rate. It has an integrated antenna and edge connector. The next sensor we'll be using in this system will be the vibration module. The module consists of a vibration sensor, the SW420, a comparator, the LM393, and a potentiometer to adjust the threshold of when the sensor would activate. So the operating voltage is between 3.3 volts to 5 volts. Operating current is about 20 milliamps, and the dimensions is 3.2 centimeters by 1.4 centimeters. The considerations. Some of the challenges that we might have in this with this with the modules that we chose is the GPS and the GSM module. Um, Myself and my partners have not worked with the module, so it will be very interesting to implement and program it.
Hello, everybody. My name is Nayara Foster, and I'm going to be talking about the phone application part of our project. So as you can see here in a block diagram, the phone application is the UI subsystem, and it's going to be composed of the user interface, the payment, the authorization, the application sign-in services. And it's going to send information to the bike when it's time to unlock the system. And it's going to receive information from the GPS module about the bike's locations, and it's going to send information to the Bluetooth about the payment process and about updates about the bikes. I created a GUI mockup design to walk you through how it's going to be the rental process in a phone application. The idea is to develop an Android app that receives serial data from the hardware device through the Bluetooth to process the information related to the bike rental. Also, as you can see, the application will have a map feature, which will allow users to locate the bikes that are available to rent throughout the campus. Initially, we were planning on using a GPS geolocation using Google Maps Service API, which is the fastest and the most accurate navigation instrument available right now. The idea is to create a dynamic system that will expedite the bike rental. So you will download the application, create a new account. Once you log in and you confirm as a user, you're going to be able to see a map with all the bikes that are available for rental. You're going to walk towards the bike that you want to rent, and you're going to press a button on the bike module. Once you press the button, you're going to receive an alert on your phone saying that the rental process is starting. And then you're going to navigate through until you get your confirmation with your name, your Z number, and the amount of time that you're going to be renting the bike. The functional requirements for these applications are: the general user shall be able to create a new account. The general user shall be able to change his or her password. The general user shall be able to reset a forgotten password. The general user shall be able to log in on his and her account. The general user shall be able to log out from his or her account. The general user shall be able to see a map with bikes available for rental. The general user shall be able to process the rental charges. The general user shall be able to see the amount time he or she have to use the bike. The general user shall receive a notification once the bike return has been completed. Now that we cover our plans for our project, we're going to talk about our project schedule and timeline. The first thing we're planning on doing is to purchase the bike that we're going to use for the prototype, and we have no dependence on that, and we are planning on doing it September the 14th. The next, it's going to be to test the Bluetooth module, and we are planning on doing October the 12th, and we have no dependence on that as well. And the following week, we're going to calibrate the vibration sensors, no dependence on that as well, and we're going to work on the locking mechanism. We're still trying to figure out if we're going to purchase or if we're going to build our locking mechanism, and we hope that by October the 22nd we will have either one purchased or built. On October the 26th, we're going to work on our first processing unit and the boards with the Arduino. And the same day, we're going to work with the other board that's going to have the GSM module. On November the 9th, we're going to assemble the GPS module unit. And for that, we're going to depend on the vibration sensor to be calibrated and the central unit 2 to be working. On November the 16th, we're going to work on the main module, assembling the unit, and for that we're going to need the locking mechanism in the central process unit 1. On November the 22nd, we will be hoping that we're going to have the phone application with the design and the code, and for that we're going to depend on the Bluetooth module, the main module, and the GPS module to be all functioning well. On November the 23rd, we are hoping to integrate all the subsystems and to create the prototype 1. And for that, we're going to depend on the testing calibration, the power consumption, and all the subsystems combined to be working. Um, and on the November, also on November 23rd, we're gonna start testing if everything goes well. And again, we're gonna depend on all the above. On November the 26th, we're gonna troubleshoot and fix everything that needs to be fixed. And by November 30th, we are hoping that the project will be completed and ready for presentation. And for that, we're going to depend on all the above. To finalize the presentation, I wanted to go over some of the references. So here are the links for all the images that we use throughout the presentation, and also the link of Balsamiq iCloud, which is the application I used to create the mock-up GUI for the phone application. And also we have the research links for all the information about the sensors, the Arduino. So I want to say thank you for everybody that watched our video, and wish everybody a good summer break.